Good morning, everybody. I apologize, but I will not be able to attend class today. So this is a video basically walking you guys through everything that we were going to do in class or that the other students are doing on Monday. So in a nutshell, you guys are going to be block 4. Doesn't really matter, but within this case, you're going to see today's folder. And in topic 7, you guys are going to want to open this up because there's a lot of links in here, and we're going to take notes on this stuff. So I'm going to walk you through just like this was normal class, and you can ask me any questions via message, email, whatever you guys want to do. But in a nutshell, these are the 3 concepts that we're going to be going over this week. So concept sketching and isometric sketching, isometric practice in Onshape. So we're going to be using what we learned today and practicing it in Onshape. And then on Thursday or Friday for you guys, multi-view drawing and line conventions. So just a little preview of what we're going to do. The goal of today is for you guys to develop a model of a realistic sketch or using a sketch to represent a design idea. So basically allowing your mind, and a lot of you may experience this when you have something on your mind, you guys just want to write it down or you want to get it out of your system. And that's what these concept sketches we're going to talk about today involve. So you're going to want something to write with today, or if you want to use Google Docs or whatever you want to take notes. I'm never going to collect notes, but it is kind of a good idea for you guys to get into the practice of taking some, because when we do finals and all that kind of stuff, all you're going to have is the stuff in Schoology, and if you don't remember what I'm even talking about, it's going to be hard for you to study. So use your own notes, get to the habit of doing that. These are the 3 concepts, or no pun intended, these are the topics for today. Concept sketching, isometric sketching, and then we're going to do a little Kahoot at the end, just so you guys can kind of practice and see how well you're getting all this information. So learning targets, we went over those already. Today's vocab. So concept sketching, a strategy used by engineers to solve problems. It's just a way of getting your ideas across really fast. So again, this is an example of like an Iron Man arm going through and showing the concept sketch in general, just sketching real quick the idea to get it across. Orthographic view or projection. This is basically a view that projects a 3D model into separate views. And what that does is allows a 3D model to be represented in a perfect world. So you'll have a top view, a front view, a right side view, and this is called orthographic projection. It projects multiple faces of an object and separates them and explodes them, basically. Proportion basically is another version kind of around the realm of scaling, and what it does is allows you to proportionally make things so that they look correct, right? As far as orientation, as far as size, all that kind of stuff. It just makes so you don't have giant wheels on a small little car when you're sketching stuff. It just allows you to represent whatever features correctly. So what I'm going to show you guys real quick is this video here, and hopefully this allows you to understand a little bit more on concept sketching and isometric views.
So, you've thought of a great new product that is going to revolutionize the gaming industry. The question then becomes, how are you going to communicate your idea to make it a reality? You may have heard the phrase, a picture is worth 1,000 words. Visualization through images, as opposed to words, allows people to absorb large amounts of data quickly. Sketching is an important skill for engineers and designers. While computers can assist in this process, research has shown that you are more creative when hand sketching design concepts. Even if you consider yourself someone who can't draw, there are some basic guidelines that can help you to create sketches that can be understood by others. An object that seems complex at first can be broken down into easier to understand lines and shapes, such as rectangles and circles. This tape dispenser has complex curves and angles that can be broken down into simple straight lines and concentric circles. The sketch may appear messy at this point, but that's okay. Note how the complex curve of the top of the dispenser can be broken down into 2 angled lines and part of a circle. You can start detailing the sketch by adding in rounded corners and smaller details where appropriate. A trick to drawing correct proportions is to break the object down using a simpler component of the object. In this case, we'll start with the wheel of the car. In terms of wheels, The car is about 3.5 wheels wide and 1.4 wheels tall. We can use these rough proportions to box the object's proportional guidelines. Hint: when drawing cars, it is easier to get the proportions right if you draw the placement of the two wheels first. After breaking down the rough proportions, use simple lines to break the object down into simple shapes. After breaking the object down into simple shapes, you can start rounding out certain details such as curved surfaces. Add in the rest of your details, and you're ready to shade in your sketch. When drawing curved objects, using simple lines to break down a shape is not enough. A curved object, such as this cup, will not appear to have straight top and bottom edges, even when looked at directly at eye level. After using flat lines to box in the shape of the cup, you will need to curve the edges of a curved object to properly convey its shape. Note the difference between the flat red line and the curvature of the top edge of the cup. Note how the curvature persists in the bottom edges of the cup as well. Hint: the curved edge of an object changes depending on how you're looking at it. The farther away the edge is from your eye level, the more rounded it becomes. This can be seen by viewing a glass with circles drawn along the outside surface at different angles. When shading with a pencil, try to avoid using the tip of your pencil's graphite and instead use the side of the graphite. If you're using a mechanical pencil, try wearing down the tip of your lead to an angle to simulate this. This covers areas easier and makes the shading smoother. Don't be afraid to use a wide range of values to create contrast, but don't overdo it. Very few items will use the full spectrum from white to black. Notably, metallic objects or dark-colored objects with extremely bright lighting. Avoid coloring in objects with only one tone. Even flat objects have a range of values, even if it's a very small range. Avoid harsh blocks of highlight and shadow. This is unrealistic and makes things look cartoonish. Avoid using flat gradients for shading curved objects. Note how for curved objects, the shading follows along the curve of the object and is not flat. Another important key to success in sketching is practice. As is true with most activities like playing lacrosse, solving Sudoku puzzles, and beating the system in Guitar Hero, the more experience you gain, the better you will perform. So consider carrying a pencil with you wherever you go. When you notice something interesting, something that can be improved, or something you would like to share, make a quick sketch instead of taking a picture. Your sketching skills will improve, you will impress your friends and family with your ability, and you will become a more competent designer.
Okay, so in a nutshell, that's it for everything that we're going to talk about today, but let's break that down a little bit so it's a little easier for you guys to understand. So concept sketching. The important thing about concept sketching and getting into multiple views and all that jazz is to first select the best front view. So a front view of an object is usually the most distinctive shaped, the longest dimensioned, and it allows you, it's called a natural view. When you have a cup, for example, a coffee cup. If I set that coffee cup down on the table, the most natural view would be eye level, seeing the side of the cup, right? That's your best front view. Even though I said side, it's still considered the best front view. In the car, for example, you'll see here, it shows that if I pick the top of this object right here, I wouldn't be able to see all of these contour shapes and all these different curves and all these lines and all that kind of stuff. It would just be a box. So this, in this case, forces this side view of this truck to be the best front view to draw. So what you're gonna do, and I'm gonna, you can just pause the video, I'm gonna keep going, but what I want you guys to do is pick something from this list, and I want you to try and practice, like you see up here, to draw the best front view of one of these objects. Don't draw it three-dimensional, don't draw it all crazy, just draw the best front view of one of these objects. It says check out a concept sketching tips and PDF, so everything that we just went over in that video is also inside of this little chart. Kind of walks you through the tips and all that kind of stuff for you guys to get a little bit more in depth. Again, just more information, the same information I should say, just in a different way. So it might help you guys, just another little resource there. If I keep going, there's another break. We're going to focus on isometric sketching now. So isometric sketching is the equal, iso meaning equal, metric, distance of an object. These are isometric views of two different objects. It's really important for you to understand equal, okay? Equal meaning if I'm looking at this cube, this is always the front view of this object. Always the front view. Always the top view. Always the top view. Always the side view, okay? Front, top, side. And they're equally represented. If this is a perfect cube, you can see this distance is represented. This is the length. This is the height. And then this is the depth. Okay, so these are iso equally represented dimensioned objects. Here's a better view of it. Okay, so you have your front view, which is the width of the object and the height of the object. You have the top view, which represents the width of the object and the depth of the object. And then you have the right view, which is the depth of the object and the height of the object. We rip these three views out of this to create what's called a multi-view drawing. Okay, this is incorrect. We don't ever want it to make it look like this. This is not the correct orientation for an isometric drawing. This is what we always want it to look like. We want the front view over here, we want the top view over here, and we want the right side over here. This is wrong. We don't want that ever. And that's just because it makes it a consistent, constant thing for you guys to get into the habit of always putting the front view here, the top view here, and the right side view here. Okay? How do we even figure that out? How do we see and know what the best front view is? If we have a weird object and it's all rotated and weird, how do I even pick? Sometimes it's not as easy as you think. So shows the longest dimension. This is just reiteration. Shows the longest dimension. Shows the best shape and characteristic contours, meaning the most funky parts of this shape. You see there's this like ramp here, inclined plane. There's this weird little, divot knocked out. If I chose the top view, I would see, again, nothing but rectangles. If I saw the right view, I would see nothing but rectangles. So I'm choosing this side because it shows the most craziest parts in a flat version view. The next thing is if these two don't really work out and you still can't figure it out, hides the fewest hidden edges and features. So we'll talk about that when I actually go into Onshape and show it. But basically anything that you can't see, okay, but still is there, like an edge that you can't see because it's behind another object, you're going to use hidden lines to identify that object is still there. We'll talk about that in a little bit. Displays the most stable and natural position. Again, natural. What comes to natural when you look at this object? Obviously, to me, when I see this, I'm going to choose this as my front view. So here's an example. This is one object that has been flipped, rotated, and twisted to be in different ways. There are multiple answers for this problem. If I look at this, the longest side is obviously here, right? This is going up and down, so realistically these two are kind of out. I want it to be a long side here, so it's one of these two that are going to be the right orientation for my isometric. But this says all four isometric views shown the same part in a different orientation. Which letter is the best front view? This is kind of like an ACT question, right? What's the best? D here does not show the longest side, so that one's out. This is kind of even though this is the front view, it's still not the longest part of this object. Ignore the front, top, right side part that we talked about in the last slide for this specific example. Just focus on this being an object, the same object, over and over again, flipped and rotated. We're trying to flip and rotate it to find the best front view. So let's look at this again. If you look at F, that's short. C, that's good. That's the longest, and it's got some contours. That looks good. But if you look, you don't really know what's behind here. We're kind of lost on what's behind here. It's kind of a mystery. E, in this case, shows the longest side. There's nothing behind here. We got this ledge out here in front. So I'm going to say E is the correct answer, and this proves that it is. To show you that in Onshape, I have already drawn that shape for you to kind of go through and see, okay, yeah, that would make sense if I looked at it in the orientation that you're trying to. So I'm going to bring that shape open. It's right here. You aren't going to have access to this, but this is just, again, to show you how this should look and what it looks good. So this is the isometric view right here, right? This is the isometric view right here. I have my front view, I have my side view, and I have my top view. If I show you what that front view would look like, it looks something like this. So if I go back here's your front view, and this is flipped and rotated the wrong way, so I apologize. But this is the correct, again, orientation. This is your perfect isometric drawing. I have my front view is here. I have my side view includes these parts. So if I click right, you'll see that is my side view. And again, if I rotate this around and go to front view, you'll see if I highlight what I see and then rotate, that is showing the front views. And then my top view, again, is these parts, or are these parts, and you can see that's all you can see from the top view. We talked a little bit about hidden edges, right? You see these dashed lines. Those are my hidden edges. I know that there is a line going underneath here, and I click off of this. It doesn't show it. If I drop this down and say hidden edges, you'll see that that little edge turns gray, and there is an edge under there, but it just can't be seen. If I go to my front view, there are no hidden edges. Again, least amount of hidden edges is my best front view. There are none. If I go to the right side, there are one, and that just means that there's something behind here. This edge is still there. Just because you can't see it in that view doesn't make it disappear. Okay, so hopefully this helps you a little bit understand. You can see that the view cube even right here shows in the exact orientation as I showed you up here, right? Top, front, right. Top, front, right. I got my front view. I have my right view. I have my top view, right? Okay, so hopefully that makes it a little easier for you guys just to see. If I keep going, I'm going to skip this part just real quick. I'm going to show you guys this Kahoot. So the link, I wouldn't click this top link for you guys. That is for if we were in class doing it together. I was going to do it and walk you through it. Not too complicated, not too worried about that. This is the self-paced version. So this allows you, if you click on it, to sign in just by yourself and play by yourself. I would like you to practice this. These are 10 questions. And what they do is they give you multi-view drawings, like a set like this. And then they give you 4 different isometric views, and you have to figure out which is the correct isometric drawing or object that matches these 3. Okay, so again, this is always going to be the front view. This is always going to be the front view, top and side. So I'm going to look at the front and say, okay, which one has this weird L? Boom, I have this weird L. I know that this object would be it. Just to show you what it kind of looks like and what some of them look like. Gabby's in here too. Isometric keeps going. It'll say play automatically. Yeah. And it'll go through these and show you basically it gives you a couple quick questions first. Top, front, side are your first questions. There we go. So as you're going to see, top, front, right, it shows you all these different things. We can go next. Keep going. What kind of drawing is this? It goes through and shows you, again, this is an isometric drawing. You're good there. And I can't skip through it, so I'm going to show you, though, other than that. I want to get through one more. 3, 2, 1. So these are the rest of the drawings. This is what it's going to look like from here on out. It's going to say which is the best isometric drawing for this specific. So select the correct isometric view. It's going to give you the top, front, and side. I'm going to say that this is, okay, it's got a little gap. It's got a backward L. This is my front view. Well, nope, that has a normal L. This has just a rectangle. This has a little gap underneath it. And then this has basically a correct orientation. So I have a bottom, a backwards left. I have this rectangle under here. So number 2 is my best option right there. And it just keeps going and gives you guys practice to do all those and to use all those. So again, use the self-pay version, go through that. Okay, for Wednesday, what you're going to do is you're going to go back into Wednesday's folder, and you're going to see that Wednesday has 4 practice problems in it. And what you're going to see inside of those 4 practice problems are 4 separate multi-view drawings. What you're going to do is you're going to take the information from these multi-view drawings and make an isometric view in Onshape. You're going to create, using these 3 views, of the 3D model of these projects. So I'm going to show you one. One quick thing I want to make sure is clear. Isometric 4, the number 4 here, if you look at the numbers, these are millimeters, okay? The other 3, 1, 2, and 3, are all in millimeters. So make sure that you guys, when you guys come into here, you go into your Onshape, which is aaps.onshape.com. You sign in. I'm already signed in, so it's not going to go crazy here. once you sign in, you go to documents, you start a new drawing, new sketch, new object, all that. New document. Let's call this ISO practice 1, right? Press OK. And the very first thing is you come up to this stack here. It's going to help you tremendously understand and see. Let's turn this off. Come up to the scat, and you're going to make sure that your workspace is in inches for the first 3. And number 4, you switch it to millimeters. Now, obviously, I'm working on number 1, so I'm going to leave that to inches. And what you're going to do is you're going to identify, and I'm going to keep this kind of up here, you're going to use this front view first, and that's what this whole thing tells you. Use the front view first. Always start in Onshape with the front view. Always. Start with the front view, and then from there, draw the 1 through 4, all 4 of them, as a solid model. So what this looks like, let me show you. If I go back to Schoology, I'm going to make this a split screen for my separate Onshape here. And you guys are going to see, you guys are going to see me draw this. So always start with the front view. So I'm going to start sketch, select front, and I'm going to move it to the front so you can see it flat on and it's nice and pretty and everybody's good. Okay, so if I scroll over a little bit just so you can see the drawing, I'm going to start with a line. Always start from the origin. The origin is hidden right here, but it's right here in the bottom left. Always in the bottom left, okay? So if I see that, I'm going to start my line. I'm going to start from the origin, and I'm going to go over. It says, if I look at this drawing, these lines represent the distance from these lines. So meaning that the overall length of this object is 2. It's all the way from here to here is 2. So I'm going to click, and I'm going to hit 2, enter. Now I have this bottom line. Go up, and it says go up 0.5. So I click 0.5. And I'll mess with these dimensions and make them look prettier in a sec, but don't worry about them right now. Now I'm going to go in. Well, it doesn't really tell me a distance to go in, but it does tell me other dimensions. So you got to use some simple math. If I know from here over is 1.5, and I know the overall is 2, I can say that this is half. So I can do that and say 0.5. You can also, I'll press escape, you can also just start going up, over, over, down, down, down. You're still going to have to do some simple math when you get here, but you can start going up instead of over. It's totally up to you. I'm going to continue what I started here. So now I have to go up. How far? Well, if I look to the right side of this object, which is over here, I can see that the overall height is 1. I know that this little ledge is 0.5. I can assume, and well, not assume, I can tell now that this is 0.5. So I can go up 0.5. And then I have to go over. Well, over how far? Again, no measurement, but you can use simple math. From here to here is 0.75. From here all the way over is 1.5. So I can do some simple math and say 0.75 across by subtracting the 2. Drop down, and again, no measurement, but I know that this ledge here is 0.75 and the overall is 1. So I can say that this drop down is 0.25. And then I can use, I don't even have to do any math in here or measurements or dimensioning. I know that by just dragging my mouse around, I can use the guidelines and like we did before, kind of lock in and then go back to close it. If I close it correctly, it should turn gray. Now for you guys to see all these and where this is all coming from, I'm going to move these dimensions out. You don't have to do this, but you can. And now I just have my part, and you'll see some missing parts. That's okay. You don't have to go through and dimension everything that you see here. Okay. Now that we use the right view and the front view to make this part, we're going to use this top view to extrude it. So I'm going to press the green check mark. I'm going to rotate. I'm going to come up here to extrude. I'm going to select the object, and I want it to be 1 inch deep. It already says depth right here, 1 inch. It's already selected, and I'm good to go. I'm going to turn off all of these other planes just so it's a lot easier for me to see. I'll expand this. I'm going to click the right orientation, and boom, now I have my front view, my top view, and my side view. Okay, you zoom out a little bit, you can drag and drop, click, drag and drop, and move this piece over to the top right, and you're going to do each of these 4 and screenshot each one. They are not due, okay? Ignore the due date. It says on there that they're due, I think like, Wednesday or something like that. Don't worry so much about the due dates, okay? I got to find, sorry. All over the place here trying to find Schoology. Schoology's not in that one. It's not in that one. Where's it at? Here it is. So inside of Schoology, you guys are going to see isometric practice problems. You're going to go through all 4 of these. And again, like I was just trying to get through and cross, it says on here Wednesday that they're due within Schoology. Don't worry about that so much, okay? Just get them done as soon as you possibly can. You'll see isometric screenshots right here. And this is basically where you guys are going to submit all 4 of those screenshots, okay? It says due Wednesday, September 30th. Don't worry about that. Just get it done as soon as possible. I'm not going to grade these until probably Saturday or Sunday. So just get done what you can and as soon as possible. When you get them done late, another little hint and a little note, as soon as you guys get something done late, please email me or message me in Schoology and say, hey, Mr. C, I turned this in late. Can you grade it? Can you get it in? And I'll regrade it or whatever case may be. Grades. Don't look at Power School yet. Look at Schoology. Schoology has the most updated grades. Power School is a little behind right now. They're trying to figure that out and get it all hooked away. The last thing, again, mice. If you need a mouse for this class, you will need a mouse. If you need a mouse, you need to email me by today. I need to know how many we need so that I can drop them off when you guys pick them up for your book collection, which is literally today and yesterday. So if you didn't miss it, don't worry about it. Still email me and we'll get you one somehow. But you got to let me know when you guys need one, okay? That's it for today. And again, so basically go through these PowerPoints or the PowerPoint that I just provided. And if you have any questions, email me, message me, whatever you need. Work on those 4 isometrics and you're good to go. Thanks, guys.